So yeah, I was actually on my, or what I thought was my deathbed this morning. Did not have a good sushi experience yesterday. Hopefully I'll be able to get through this okay. How's everyone doing? Break went well? Yeah? Before we get started, everybody stand up. I'm not kidding, everybody stand up. I'm not gonna just like stretch or something. I don't know. Yeah, stretch your neck, go like that, whatever, like, ugh. Yeah, small circles, whatever you want to do. Let's just do a little stretch minute here. Get the blood circulating, make sure your brain can think. So I'm going to be talking about build systems. Everybody can sit down now. So build systems, the next generation. Quick plug, I work at a JavaScript shop based out of Phoenix called Fractal. If you do a lot of open source JavaScript stuff, you've probably heard of us. We have around 150 open source projects, 140 of which are node modules. So we're pretty high up there when it comes to that. I want to do a quick hater shout out before I start talking about anything. And yes, that's some Salt Lake City GIF that I found. It looks pretty cool. So local. For those of you who say make works fine for a web app build step, I just want to say, you having a laugh? Make is not optimized for modern day web development. I won't be bringing up Make, Ant, or Maven in this talk. This talk is about JavaScript build systems for a JavaScript conference, so I will not be talking about those. So we've identified what isn't usable for web development. What do we have out there that can help us do our jobs more efficiently? Before we get into that, let's just step back a little bit and think about some concepts here. We're going to talk over some philosophies behind build systems and different approaches to creating a build system. So I want everybody to close their eyes. I see people down here, eyes not closed. Close your eyes. Picture a build system in your head. It should read files, modify them multiple times, then save them. Does everybody have something in their head? Open your eyes. You most likely thought of something like this. This is a file-based approach, and files are read from the file system, passed through each transformation, then written back to the file system after all the transformations have been completed. So just in this little video that I made that took me forever to make, actually, Final Cut is kind of hard. We're passing multiple JavaScript files from a folder. We're giving it to concat. That outputs one JavaScript file, which then goes to minify, which then modifies that file, pass it back to the output folder, and then we see some little sunglasses drop on them. So this is, in my opinion, the correct way to do this. I will discuss alternative ways to do this as well. This is probably what you didn't think of, but what you know. How many people here use grunt? How many people here use make for a build step? One. How many people use gulp already? A couple people? Cool. So grunt is actually this task-based process. So in this approach, we treat each transformation as a different task on its own, with the input and output being the file system. So every task has an input folder and an output folder. So I think task runners are fine and should exist, but they don't fit very well for build systems. They're not performant, and I just don't think the philosophies align. So the biggest problem with the task-based approach is the lack of context between transformations. So when processes can't share information, we need to use the file system to fill this gap. So we're storing all these partially processed files to these temp folders. So I'm sure, how many people here have experienced grunt hell? Almost as many people who said they use grunt. So I think that is just a good indicator that this is not a good fit for a build system. So for those of you who don't know what grunt hell is, it's made of temp folders and temp folder management. And essentially what you have to do is after each task, you put stuff into this temp folder. Then when your next task starts, you read it from that temp folder, do some processing and continue. And then once everything's done, you go and wipe all these temp folders out. Not a very good idea. So the more tasks you make, the worse the performance is with this. And a lot of times people will just cram everything into one task. That way they don't have to do these temp file things. So you end up with these huge monolithic tasks that decide that they pretty much just want to do everything for your web app. So you give it one input folder, which is your whole app, and one output folder, which is like your public folder, and it just does everything. And these take like thousands of config options to figure out how to do everything and which stuff to enable. It's not a very good idea. So I just think task-based systems don't make sense with the way we build things today. The apps of today are heavy on transformations and deal with lots of files. We simply can't shoehorn task-based systems to be good build systems. I also think we don't need task-based DSLs. I think that these DSLs around tasks just obscure the expressiveness of JavaScript. They limit you as to what you can do. I have hit this problem so many times where you end up programmatically generating a grunt file because you need some flexibility, and you just can't do it with a DSL. So I think that it's better to just not limit people to these DSLs and keep people using vanilla JavaScript. So JavaScript already has a task system, actually, built into the language. You may know them as functions. How many people here have used functions before? I hope everybody should raise their hand. If you use JavaScript, I hope that you use functions. I don't know how you do JavaScript without using functions, for those of you who didn't raise your hand. I'd like to hear about it after, though. So here's a simple example of using functions in JavaScript. We create a function, we give it a name, then we call it. So this is pretty complex. I'll give you guys a second to let this soak in. So after you call the function, the stuff inside the function has been executed. Now, it's kind of hard to wrap your head around this. I know I'm being really facetious. Be euphoric in this moment. You are now enlightened by your own intelligence. So we know task-based systems are not the right solution here, so how do we get into this file-based business? The answer is with streams. How many people have used streams? How many people know what they are but don't see a reason to use them? Oh, cool. So here's a great quote by Doug McIlroy that explains the concept well. He said, "We should have some ways of connecting programs like garden hose. Screw in another segment when it becomes necessary to massage data in another way." So essentially, your application is not a big truck. It's a series of tubes. So why are streams such a good fit for a build system? Well, streams provide a way to compose large systems out of small components. Using streams, you can simply plug the output of one stream to another and swap components in and out as needed. Higher-level libraries that operate on streams give you flow control, like forking and merging of streams. So I'm sure everybody's used Unix streams before, A, pipe to B, pipe to C, pipe to D. So it looks pretty similar in Node, A.pipe to B, pipe to C, pipe to D. So streams aren't really like this shiny Node thing. This concept has existed for quite some time. I think that quote from earlier was from back in the 60s. People have been using streams for a long time. They've been in Unix for quite some time. But Node has it built in, and every Node API has a streaming counterpart. So this is why everybody in Node is crazy about streams, is because everything is streaming by default in the Node core. So the community has widespread adoption for streams, and there's thousands of modules on NPM that support streaming or only streaming. So you can start playing with these today, and you can make some really cool stuff. So now that we talked a little philosophy, let's look at some real code. In this, we're just going to compare a task-based and a file-based build file for a simple JavaScript project. So with this file, we will lint some JavaScript, concatenate some JavaScript, minify some JavaScript, and then we want to run it again every time the files change. So this seems pretty common, right? So using grunt, can you guys see the code okay on this? Yeah? Can we turn the lights off at all? Maybe? Okay. Dark color is not a good idea when there's lights. Cool. So anyways, I'll just explain this. We have this function that takes in grunt. We have this big JSON blob that describes what we want to do. So we say concat, here's an option. We want, semicolon to be the separator. We tell it, okay, this is my distribution files. Here's the source files. Here's the destination files. And then we do the same thing for uglify. And the same thing for JS hint, and the same thing for watch. So with watch, we just give it an array of tasks that we want to rerun. So this is a gulp file. Gulp is a file-based build system that uses streams. I am the creator of gulp. How many people knew that? No? So I have a little bit of a bias here. I like streams a lot. I think they fit really well for build systems. So here's some things to notice that are actually quite a bit different than the grunt file. So concatenate and minify are actually one task, and input is only read from the file system one time and written one time. So, oh, that doesn't work. Yeah, I really should have gotten a laser pointer. So yeah, we see our compile task right there at the top, gulp.src, we give it our script file folder, or our glob. We pipe it to concat, then we pipe it to minify, then we pipe it to our output folder. So, yeah, this code is very node-like. There's actually no DSL to learn, and you can almost immediately tell what's happening. All the streams in Gulp are vanilla node streams. They'll work perfectly fine with all the other thousands of node stream modules. You can use them with node core streams, and they're just very performant. So you can see the plugins look quite a bit simpler too. Like concatenate doesn't take this big options object. In Gulp, we actually have this philosophy that plugins should be really simple and only do one thing. The concatenate plugin should only concatenate files. It shouldn't like do some crazy thing if it's a CSS file or like act differently on a JavaScript file. It just takes file 1, file 2, file 3, puts them all in one file, back out you go. If you want to do anything else, you just use a different plugin for it. So Gulp actually has like 460 plugins the last time I checked. So pretty much anything you want to do, you can do it with Gulp. So just to revisit this, task-based I/O costs, they increase with the number of files and the number of tasks. So the number of reads you have to do equals the number of files times the number of tasks, and writes is the same way. So you can see as your build system becomes more complex, your performance is going to drop. So when you have like hundreds of files and like 10 tasks, that's a couple of seconds to do a build, right? And you might not think that's a big deal, but how many people here use live reload as a part of their build process? A couple people. Just for those who might not know what it is, it's pretty much every time you update a file, it'll refresh your browser and pull in all the latest changes, and that's a really rapid way to do development because you can type save and it's already over there. So when you have these 10-second build times, you're losing 10 seconds of your life waiting for the browser to refresh. And personally, I care about those 10 seconds, and if you think and you're programming all day, how many 10 seconds are you losing every day? You could be losing hundreds of years off your life. So as Matthew McConaughey would say, time is a flat circle. Now this actually doesn't have anything to do with this talk or apply to build systems in any way, but I do like True Detective. True Detective fans, anybody? Woo! All right. So file-based systems come with their own set of problems. They're not perfect either. The biggest problem is third-party modules, like require.js, for example. Basically, third-party modules love to handle their own I/O, so you can see how this causes issues with the system that tries to do everything in memory and has this very opinionated I/O system. It's very difficult to get these third-party modules to work correctly unless they like just take data in and put data out. Like require.js, for example, their API, you just give it a folder and it does everything. You can't really control it in that way. So when you have multiple steps and then you want to do a require.js, well, guess what? You're stuck doing temp folders again. So where's the benefit there? So in theory, you could have a perfect build system and do everything in memory, but in practice, third-party modules don't like this, and they're very hard to work with. Yeah, so I'm working on like a couple of ideas to solve that problem. Basically, I want to like wrap these third-party modules in a sandbox almost, and like override the FS module to read from an in-memory set of files, essentially tricking these third-party modules into thinking that they're hitting the file system, but they're actually not. So that's just one way that you could solve it. I know Broccoli. Who's heard of Broccoli? Yeah, I know Broccoli does temp folders, but they manage the temp folders for you. To solve that problem, Joe List, the creator of Broccoli, does not think that doing stuff in memory is feasible, but Call me an optimist. I like to think that one day we could have this perfect build system where everything is in memory. Cool, so let's talk about gulp a little bit. Before we get started into this, let's talk about what I mean when I say max concurrency. So in gulp, tasks can have dependencies and other tasks can have dependencies, and you have this whole dependency graph, and gulp keeps this like this big tree of all this stuff. So when you run a task, for example, let's say build, and build relies on clean, and also you have build 2, which relies on clean. You run build and build 2, it's going to run clean, and then it's going to kick off build and build 2 at the same time. So it creates this like orchestration of tasks to run with the most tasks running at one time as possible. So by default, everything in gulp is run at the same time. You kick off 5 tasks, all 5 tasks run at once, because due to the fact that we do everything in memory, we don't have to wait for other stuff to like write to these temp folders and then read from them and keep going. So it's a lot more performant. I've seen people have like gulp files that are 100 times faster than their equivalent grunt files. It's fast. Those seconds add up, folks. So gulp has like 3 functions that you have to learn. If you know JavaScript, you know gulp. This is like our catchphrase. So this is how you define a task. You say gulp.task, you give it a name, you give it a function. This lets you call this function from the CLI. We actually support the node callback pattern, returning promises, and returning streams. So if your task is actually just creating like one pipeline, like gulp.src, pipe to a couple things, pipe to dest, you can just return that, and then the function will be over when the stream has ended and all the files have been processed. So it's pretty sugary in that way. So gulp.src is where a lot of the magic happens. You just give it an array of globs, and as it walks the file system, it's going to start emitting these files. So in other build systems, when you give it a glob, it synchronously goes and walks the whole file system, gets all the files, reads all the files, bundles them all up, and then starts working on them. So with gulp, since we're using streams, actually like the second it finds the first file, it pipes it out, it's already getting processed. So if you have thousands of files, they're going to get processed a lot faster just because they're getting processed lazily. So gulp.dest, this is what you pipe files to, and you just give it a folder and it writes the files to the folder. Simple enough. After the file is written, it's re-emitted so you can keep processing and putting it in other folders if you want to, and this lets you do some cool things like this. So in this example, we take in some source files from js/star/star.js. We concatenate them into all.js. We pipe that to the build folder. So we have our unminified version. Let's just say this is like an open source library or something. So we have our unminified version in all.js. Then we pipe it to uglify. Then we pipe it to a rename plugin, which changes the name of the file to all.min.js. Then we pipe it to build again. So now we have 2 files, all.js and all.min.js, that were done with the same task. So there was still only 1 read here, but 2 writes. So some takeaways. This is just what I'd like everybody to see, even if you don't use gulp. This is just what I want you to learn from this. Code is more terse than constructing some JSON DSL. Code is more expressive. Code is more flexible. Streams are awesome. Use gulp.js. Learning how to use streams will make you a better programmer. Learning different control flow techniques and different ways to solve problems is what makes us programmers. So if you want to check out streams, Stream Handbook by Substack is really good. It's just like a markdown tutorial of how to use streams and all about like the different intricacies of like streams 1 versus streams 2 and stuff. So that's up on github.com/substack/stream handbook. I wanted to show a gulp file I actually used to make these slides. So I built this custom slide framework that's all hinged around gulp. So we have this assets folder. We have this decks folder, which is all the slide decks. So you can see my build systems.jade is in here. The whole thing is just Jade mixins. So every time I make a new slide, like a title slide, for example, with a GIF in the background, I'll make a mixin for it. That way I can just reuse that code across all my slideshows, and I get like a consistent interface. So I have like, pretty much if I go change this mixin and I build my slides again, it'll propagate against all slides I've ever made. So I think that's really cool. But the gulp file for this is really simple. So we load in all our plugins up here, then load in some Node Core stuff, pick some folders, so assets, decks, and presets. Presets actually isn't really that useful. That's just a command that I can run to create a new slideshow, and it just makes the file in the assets folder and everything. But the real meat is right here. So gulp.task slides, and then I just say gulp.src dex/star.jade pipe to jade pipe to gulp.dest public, and then I pipe it to the live reload plugin, which then takes the path off of the file and publishes that to your local live reload server, which then Chrome is listening to and refreshes it. So as I'm working on my slideshows, I see the updates instantly because it's being watched in that way. So then for the assets, I just take every file in the assets folder, I pipe it through the ImageMin plugin that optimizes all the images, I pipe it to public/assets, and then I do the same live reload thing. Same with lib. CSS files get optimized by CSS optimizer. JS files get uglified, and then those go back into public/lib. So you can see in like this tiny little function, like this 5-line function, we're doing more than you could do with like 50 lines of grunt config, just because like this would be really difficult to do as performant in grunt. I don't think that it's possible actually, but cool. And then we have our watch task down here that just sets up all our watches and says what tasks to run when any of these files change. And that's it. Pretty cool, right?